Hello and welcome back to Black Hole Battles game development here on Let's Code Physics. Last time I said that we have done a pretty good job of testing out our individual enemy ship behaviors, and now it's time to put those things together into sort of a strategy. And that's what I've done for you today, and so that's what I'd like to walk through and take a look at. You can see it in action in this panel over here. We'll go over what the ship is doing. So over here we've got a basically a decision tree set up based on the ship trying to stay alive. So the ship is not trying to engage in combat with the player. It's not trying to do anything nasty. It's simply trying to keep moving around the playing field and stay alive. So the first thing that the ship is going to check for is whether it needs to head back toward the cluster. So this condition here, this max angle and min angle, is evaluating whether the ship has gone outside of the cluster of black holes. So this max angle and min angle, I added a calculation of those up here where we are looping over all of the black holes. Basically what it's doing is it is checking for the angle that the black hole makes with the ship. So for example, if you think of the ship as the origin, this is where that black hole is located from 0 to pi, or from 0 to negative pi in terms of the ship's coordinate system. And so it's keeping track of which one is the farthest away in terms of a counterclockwise rotation, and which one is farthest away in terms of a clockwise rotation. Excuse me. No, I had that right. Yeah, in terms of clockwise rotation and in terms of a counterclockwise rotation. And so if the ship is inside of the black hole cluster, then that max angle and min angle should be, the difference between those should be greater than pi, because it's being surrounded by them. But if that difference is less than pi, so say the ship is up here somewhere and the cluster is down here, then that largest angle is going to be less than pi. And so in that case, it's going to try to get back to the cluster. So it's going to start heading back that way. And so we're using the go to next nearest black hole command, and just telling it, okay, start heading back toward the cluster, avoid the closest black hole, but head toward the next closest black hole. I've put that in there because I don't yet have a routine for just going toward the cluster. I'll probably need to replace that at some point, so I'll probably before the next update I'll replace that. Otherwise, it's going to check for whether it should head toward the next for whether it should go between black holes. So this again is checking for whether it is basically equidistant between two black holes. So what it's checking here is the distance between the ship and the closest black hole and the next closest black hole. It's taking the relative difference. So the way you get a relative difference is you take the difference, divide it by the average, or just the sum, and multiply it by 2. And we're checking for whether that's less than some equidistant tolerance. And so this equidistant tolerance is basically how close are we willing to say that two things are equidistant. And so that is a moderately sized number. I think I have that set to, what do I have that value set to? I suppose I could just search, couldn't I? Okay, yeah, I've got that. I've got all those set up in this block here. The equidistant tolerance is 0.1. So basically, if those are within 10% of being equidistant from each other, which is not bad. So that's anywhere from 90% the same distance to 110% the same distance. Now I'll use the search function. What I don't yet have in here is checking for whether they're both in front of the ship. So that's something else I'll need to add, because there's no point in having the ship try to go between the two black holes if they are if they're behind the ship, if the ship has already passed between them. So that's probably leading to some strange behavior. Otherwise, it checks for whether the two closest black holes are basically collinear. And so if the two black holes are not collinear, I guess I should say. So what it's checking there is checking for the angle that's made from the ship to the closest black hole and from the ship to the next closest black hole. So it's taking this arctangent of that angle here. And basically we take the absolute value of it so that we don't worry about which one is, to the left or to the right. And basically if that's greater than the collinear tolerance, our collinear tolerance is set to 0.3. Notice this one's an absolute comparison. This one is a relative comparison because this one is a distance. But this one here is an angle. And so you don't really have a relative size of a single angle. And so this one we're saying if that's greater than 0.3 radians, we don't consider it to be collinear. If it's less than 0.3 radians, we do consider them to be collinear. And so if they're not collinear, meaning it's okay for it to avoid one black hole and go to the next nearest black hole, then we're doing the go to next nearest black hole command here. Otherwise, if it's got two nearby, so basically otherwise if it's got two nearby black holes, and neither of them, and they're collinear, it can't pass between them, it can't avoid one and go toward the next one. Otherwise, we have evasive maneuvers, and it is just going to avoid the closest black hole period, and then the next frame will evaluate whether whether the ship can do something else. So this is sort of the default, and then these are all the exceptions, basically. And in order to observe this, I've done a couple things. First of all, I'm having the, let's skip all the way down to the bottom here, sorry. In order to observe this, when the ship runs into a black hole, because that's going to happen eventually, it's going to print a message that it died, and it's going to tell us what it died doing. So this death message gets set within each of those blocks up above. Let me show you what that looks like. Death message. Yeah, so death message is whether it's returning, whether it's going between, whether it's going to the next nearest black hole, and whether it is avoiding the black hole. And so basically it tells us what it was doing when it died. So that helps me, or that's going to help me figure out what behaviors I need to adjust and what conditions for those behaviors I need to adjust in order to keep the ship alive for longer. And then it just reloads the scene. I've got some stuff printed out here because I'm trying to get it to write all that to a file, so I'm having to learn how to write to files in C#. And I am slowly learning that, but I'm not going to bore y'all with those details, so I'll just have it printed to the console for now. Let's see. Oh, the other thing I've done that has been pretty helpful is I'm speeding up the timescale. You might have noticed that the ship was moving much faster than it was last time. That's not because I gave it better engines, although I probably should give it better engines. That's because I've increased the timescale. So it's moving. So the game itself is moving 3 times as fast as it was before, just so that we can observe those collisions a little bit more frequently. So you can see while I was doing my intro, the ship died twice. Once it died during the go to next nearest black hole, and once it died during the returning subroutine. I'm going to clear those errors. I'm still not sure why it is telling me it has an index out of range. I think I know it's doing that every time it loads the level. I need to zero in on that. So let's run this, see if we can get a couple of death messages. Boy, that sounds dark. Boop. Okay, so there it died, going from the nearest black hole to the next nearest black hole. All right, here it is going well outside the playing field, so now it is returning. Now it is trying to avoid, and now it's trying to go, I guess now it's going next nearest, so we might get to see a death message here. Okay, so it's trying to avoid this black hole and head toward this black hole. Cool, that was a success. Of course, now that I'm pausing and looking for death messages, it's not going to die. Okay. So now this one will be interesting to see. So it was passing from here to here. So it was going from this one to this one. And now I suppose it's trying to go from this black hole toward this black hole. Let's see what happens here. Slow motion. Is he going to avoid it? Anybody want to place bets on this? Ooh, it did avoid it. Wow, that's nice. I'm remembering to press pause to unpause instead of play to unpause. This one, it shouldn't be trying to pass between this. It should be trying to go from this one to this one. Let's see what happens here. Oh, okay. It's turning in the wrong direction to be going toward this one. I wonder if it's trying to go toward this one instead. Oh, and there it died. Actually, it was doing the returning routine. Okay. Oh, which the returning routine is the same thing as the next nearest black hole. So that tells me that I probably do need to have a different behavior in the returning part. So I probably need to make that its own behavior. Change this to be its own behavior. Cool. So I've run it a few times off camera, and it seems to die most often during the go to next nearest black hole. So that I think is going to be the one that I focus on. Just because, if that's one that's causing the ship to die most frequently, without me doing anything, right? I'm not doing anything to this ship. It has no problem running past me. It does collide with me, which I could remove the ship, but I would have to change other things in the code that are dependent on the player ship. So I'm not gonna worry about that now. If he collides with me, then that's fine. Oh, he died doing next again. Let's see. And so basically, what I'm gonna do as a test for this is up the time speed to like 50 times the default, and then I'll try to have it write out to a file, and then basically what I can do is I can identify the percentage of the time, the percentage of the runs where the ship dies during each type of maneuver, and that'll help me. Oh, there he goes. Died doing returning. Now, that's weird because he was inside the cluster. He should not have been returning at that point. So I don't think I have this set up correctly. This is not set up correctly. Because he was definitely... I'll go back and check on the replay. But, actually, let me leave a note. Check on replay. Because he was in the... He was inside the cluster at that point, so I think I've got a mistake or an oversimplification with that. Let's see what happens here. Yeah, I might have that oversimplified or somehow. Okay, well this run seems to be doing well. Which is why I'm randomizing the... Oh, there we go. He died doing next. Okay. Oh, careful. Oh, there he goes. Yeah. So, now there he knocked me into the black hole. There he goes. Yeah. So it definitely seems like from this limited sample size, the going to the next nearest black hole behavior is causing some issues. So basically, what I have to do is I have a few parameters I need to tweak. First of all, I need to fix this piece here because it seems to be calling that more often than it should. But then I can tweak this equidistant tolerance so that so if it's going to go to next nearest black hole too often, I can either increase this equidistant tolerance so that it tries to pass between black holes more often, or I can decrease the collinear tolerance. Or excuse me, I would want to increase the or I can increase the collinear tolerance so that it calls this less often and goes to evasive maneuvers more often. Because I'm pretty sure I've got the individual go to next nearest black hole down pretty well. I can play with the danger smidge here. Yeah, so I can play with that. I should probably make that a global variable up at the beginning. But because everything else is basically evaluating. Yeah, everything else is based on that danger smidge. That's the only thing I can play around with that. Everything else is based on the geometry. What did we miss while we were gone? We got an avoiding, a next, a next. We got a... Oops. We just got a next. Okay, so that tells me that next nearest black hole behavior is one I need to adjust. Brian, you're going to cut here because you're checking how long. All right, I said I was going to record 20 minutes. That's 18. Okay, so that gives me an idea of what I need to play around with. I might start with that danger smidge just to see, what type of... Oh, there he got me. Don't feel too bad for him. He's getting some victories in the middle of this with me doing absolutely nothing. So what I'll try next is adjusting that danger smidge. I think that'll probably be the first place I start. And then I'll also play around with those tolerances, get this thing better automated, and then I'll have some more aggregated results from a larger sample size to try to play around with. In the meantime, though, I'm going to see if I can get this guy in a black hole. Wow, this game is rather difficult with an increased time speed. Okay, I got him there. Whoa. All right, I'm not even watching my main screen. I'm watching the scene view here. All right, so I'm going to have some fun with this. I will see y'all next time. Have a great day. Bye-bye.